The astronauts read out
Gravitational effect of those planets.
Hi, I'm Matt, and this is NASA Now. Have you ever thought about the air we breathe? What affects it? What's it made of? Today, we're going to discover what's been hanging around in our atmosphere. That's ahead. But first, here's what's happening at NASA Now. Scientists announced a major breakthrough in mapping Antarctica's ice flow. NASA-funded researchers have created the first complete map of the speed and direction of the ice flow on the world's southernmost landmass. As one scientist said, this is like seeing a map of the ocean's currents for the first time. It's a game changer. The new maps, which show glaciers flowing from thousands of miles from Antarctica's deep interior to its coasts, will give researchers critical knowledge in predicting variations in sea level caused by climate change. Now, let's take a look at the past.
October 1998, the American Geological Institute organized the first series of international events called Earth Science Week. This year's theme is Our Ever-Changing Earth. You can find out more on the NASA Explorer School's virtual campus.
For decades, scientists have been working to gain a better understanding of our atmosphere. It's no secret that we humans are having an impact on the air we breathe. So how do scientists measure this effect and what can they learn? Here to fill us in on the science of studying our atmosphere is Dr. Kenneth Pickering from the NASA Goddard Space Flight Center. Hello, Dr. Pickering. Can you tell us about the different parts of the atmosphere?
Well, the atmosphere is the layer of air that completely surrounds the Earth. It really changes quite a bit with altitude as you go up from the Earth's surface. There are several layers of the atmosphere that each have its own importance. The lowest layer, closest to the ground, is what we call the troposphere. This is where all the weather occurs. The second layer is the stratosphere. It strongly absorbs ultraviolet radiation and allows only just a very small amount to reach down to the Earth's surface where we live. If it were not for the stratospheric ozone, we would suffer terrible sunburns and horrendous rates of skin cancer. Next, we have the mesosphere, and there are many important chemical reactions that go on there that are really driven by sunlight. And then above that is the thermosphere, where most of the molecules have become charged, so they're ions, and that extends out to at least 100 kilometers or more.
Why is it important to study the atmosphere?
The atmosphere is a very important part of the overall study of Earth science because it interacts so strongly with both the oceans and the land. There's a lot of transfer of heat between the surface and the atmosphere. When the sun strikes the Earth's surface, it heats the layer of air right above the surface, and if there's sufficient moisture, this will cause clouds to form as that warm air rises. Over the oceans, a large amount of water vapor that evaporates from the ocean surface also leads to a considerable amount of water vapor that gets transported through the atmosphere.
What's in the atmosphere?
The largest component is molecular nitrogen. It makes up almost 80% of the atmosphere. And then second is oxygen, which of course is very important for plant and animal life to exist on Earth. That's something we absolutely need to breathe. Then there are many other trace gases in the atmosphere, and probably the two most important of those are water vapor and carbon dioxide. Carbon dioxide, of course, has been increasing as more and more fossil fuels are being burned. Then there are much more minor components, and these are the things that we call air pollutants.
What kind of atmospheric studies are going on right now?
Discover AQ is a NASA-sponsored field project that was conducted during July 2011. During that project, we flew 2 NASA aircraft to study the chemical composition of the atmosphere in the Baltimore, Washington area. This is a highly polluted region where there's a tremendous amount of emissions from automobile traffic. Also, other sources of air pollution, such as power plants, also contribute. One aircraft was a plane that carried about 9 instruments and measured everything from nitrogen dioxide, ozone, carbon monoxide, the carbon dioxide, and many types of measurements for atmospheric particulate matter. The second aircraft was a remote sensing aircraft. That had instruments that looked down from a much higher altitude, such as a satellite would. The overall goal was to be able to use these data to better interpret what satellites are measuring from space and to be able to better forecast air quality down the road.
Did you know that according to the U.S. Environmental Protection Agency, that the average adult breathes in 3,000 gallons of air per day? Now you know.
Now it's time to check out what's up.
NASA not only launches rockets into space, they also track hurricanes. For the latest hurricane information, check out this website.
A picture is worth 1,000 words, and photography can play an important role in scientific research. Now here's a contest where you can get some practice.
Time is running out for you to enter the Earth Science Week photography contest. Visit their website for more information.
Well, that's it for NASA Now. Be sure to tune in next time when we'll break the sound barrier. See you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.